Okay, write down today's topic, work, power and energy. Write down today's topic, work, power and energy. Work, power and energy. Here very simple lesson, directly target for part A section, part A applied paper section. Okay, consider here a particle, so given a force P, then corresponding to that, let's say displacement x here. Here displacement x, initial position A, end position B. So because of that motion, because of that force, there will be a work will be done. Okay, then that work we say force into displacement along the force into displacement along the force. Then W equal P times X. Here usually measured by Newton meters or joule. Here W equal P times X. Here this is we call work. Then actual definition of this work, consider here force is a vector P and let displacement simple x vector x. Take this angle theta. Then actual definition of work given by vectors, dot product. Then work equal P dot x. Here that is given by P dot x. Modulus P, modulus x cos theta. Modulus P, modulus x cos theta. Then force into displacement along the force. Force into displacement along the force. That is we call work. We call work. Okay. First write that one. Then you see power. Here we say work done per unit time. Then W equal P times X now. Then differentiate this. dW divided by dt, dPx divided by dt. Then we denote this one by H. Here P constant, take it outside. Dx divided by dt. Then displacement divided by time, we say velocity. Then H equal PV. Here H equal PV is the equation. Formula. H equal PV is the formula. Then here you consider here a vehicle which has engine. To move this engine, there must be power given. That power we say P. And here corresponding power. Here force P. H equal PV. Okay. By the engine, that power will generate. Then H equal PV. Then usually H measured by watts. Then there's another 1 horsepower. 1 horsepower means for 746 watts. Here just unit conversion. 1 horsepower equals 746 watts. Then H equal PV. This is we call power. Work done per unit time. Okay, put that on as well. this power P, we specially say tractive force. Tractive force. So that tractive force has generated by the engine. The tractive force has generated by the engine. Okay. Then next one, energy. Energy. Then you consider here an object with mass m with velocity v, which at height simple h from E0 level. So here this has kinetic energy that is half m v square, then potential energy, gravitational potential energy mgh. Here that is energy. Okay, and further you consider a spring. So here let this natural length L, say extension x. Then here there will be elastic energy will be stored. Then elastic energy delta EV is say half kx square. Here elastic energy, k means spring constant. Then further we can write delta E half lambda divided by Lx squared. Same relation. Or you can write delta E equal half Ya divided by L x squared. Okay, this can be string or spring, whatever it is, okay. Here this is spring or string. So K we call spring constant. Lambda we call modulus of elasticity. Then Y call Young's modulus. Y we call Young's modulus. So usually in mathematics we consider about this. Half lambda over L x squared. Okay, that is stored elastic energy. Here all are given by elastic energy. Okay, better write them. That is about energy. Okay, then finally, here there's special thing, that is unit conversion. 1 ton equal 1000 kilograms. And 1 to 100 inclination, 100 is to 1 inclination. Inclination is here, that represent here angle theta, sin theta 1 over 100. Then further, a constant velocity or maximum velocity that represent acceleration 0. Acceleration equals 0. So constant velocity say acceleration 0. Maximum velocity also say acceleration 0, because further we can't increase velocity. Here you better to put this note. That's all about work, power, energy theory part. Take your tutorial. Page number 1, 2005 A-level question. Start it. Page number 1, 2005 A-level question. Start doing it. First read well. A lorry of mass capital M kilograms with its engine working power h kilowatts has maximum speed u. Has maximum speed u mean acceleration 0 on a horizontal road with the engine working at the power. With the engine working at the same power, maximum speed of the lorry up a road of inclination alpha to the horizontal is v. If the resistance is unchanged, find the value of h. Find the value of h. So here this case usually we have one equation h equal pv. H equal pv equation, we have only one equation. Then p mean tractive force, h mean power. Then with that one you can apply Newton's law, F equals ma. And also you can apply equation of motions. V equal u plus f at, s equal ut plus half at square, v square equal u square plus 2s. Likewise, you can apply all. Then first case, you better to sketch diagram first. First sketch diagram, 2005. Here lorry of mass capital M in kilograms, say mg. Working at power, it has engine, its power h kilowatts. Then multiply by 1000, convert into watts. It has maximum speed u. Maximum speed. Therefore, it says that acceleration 0. So here power given, no? Then there will be tractive force P. You better to mark that tractive force P. And again there will be resistance R. Then you can apply H equal PV formula first. H 1000, H tractive force P, velocity given U, then P equal 1000 H divided by U. 1000 H divided by U. Thereafter, use horizontal F equals ma. We have specially H equal PV and F equal ma equation with equation of motion. P minus R, mass capital M into acceleration 0. Then R equal to P. 1000 H divided by U. Then R value 1000 H divided by U, resistance. Then against same resistance it moves. Against same resistance it moves up a hill. Inclination given alpha. Here P, capital Mg, resistance R. Resistance R. Now here velocity V, maximum velocity. Therefore acceleration 0. Then you mark new tractive force P1, na? Because tractive force can be differ. Then use this say F equals ma. Then P1 minus R minus mg sin alpha equal capital M times acceleration 0, because V is the maximum speed, V. Then P1 R plus mg sin alpha. Then R already known, 1000 H or U. mg sin alpha. mg sin alpha. Then use H equal PV equation. Now power can be different, no? Tractive force P1, 1000 H over U plus mg sin alpha times velocity v. V. Here new power. New power. Time to time power can be changed, okay? Same h, same power කියලා තියෙනවානේ, same power h. Tractive force P1 V 1000 h, 1000 h divided by V. Then substitute here 1000 h over V, R mean 1000 h over U equal mg sin alpha. Then find h value. Find h value. Mg sin alpha divided by 1000. Here 1 over V, 1 over U. Here h value. Mg sin alpha over 1000, 1 over V minus 1 over U. Two 2011 question started 2011. Total mass of the cyclist and his bicycle m kilograms. When he rides directly up a road, inclination at an angle alpha to the horizontal at a constant speed v against resistance r. He works at constant rate of h kilowatts. H kilowatt. He moving up a hill. Here capital M kilograms, inclination alpha, mark resistance r. There will be tractive force P. Resistance R given. Then velocity V. Constant speed. We are given constant speed. Therefore say acceleration 0. Then upward use F equals ma. P minus R minus mg sin alpha. Mass into acceleration 0. Then tractive force equal R plus mg sin alpha. Then use H equal PV formula. Then power H P R plus mg sin alpha. That instant velocity V. That instant velocity V. H equal R mg sin alpha times V. R mg sin alpha times V, no? Okay. Then you start from 2014 and continue up to 2021. 2021. Start from 2014. Two 2014, a vehicle of mass m pulls trailer of same mass light inextensible spring, by light inextensible spring. Here the vehicle and here the trailer. mg same mass, mg along a straight track. Resistance of motion of the vehicle, capital R given, and here 2R given. Here there will be tension T, then here power P kilowatts, and mark tractive force P1. Here tractive force. And vehicle moving with speed V. But here that is not given constant velocity or maximum velocity, no. Therefore, definitely there can be acceleration. Okay. Then you better to mark acceleration A. Acceleration A. Now consider system. This way F equals ma, tractive force P1, total resistance 3R, total mass 2m, acceleration A. Same time source H equal PV, power given P kilowatts, then here 1000 P, tractive force P1, that instant velocity V given, then P1 equal 1000 P over V. Then put it here, 1000 P over V, TR 2m A. Then find acceleration m, divide by 2m, 1000 P divided by 2m V, 3R divided by 2m. The acceleration. Thereafter, you consider only about trailer. Use F equals ma horizontally. Then tension T, mass capital M, here T minus 2R equal ma. T minus 2R equal ma. And tension equal to R plus ma. A 1000 P over 2 mV. Three R divided by 2 capital M. Here it is. Now you simplify this one. Simplify. And 2R 1000 P divided by 2V, 3R over 2. Then here R divided by 2, 1000 P divided by 2V, take 1 over 2 outside, R plus 1000 P divided by V. That is in newtons. That is 2014. Do up to 2023. Continue. Okay, then 2015 A-level question. A vehicle of a lorry of mass capital M metric tons. Consider metric ton both same, 1000 kilogram. Moves with constant velocity u along straight level road. Here it is. Velocity u constant. Constant velocity. Therefore say acceleration 0. Then mark tractive force P. Then is power given H kilowatts. Then 1000 watts. then resistance R, then use F equals MA, P minus R equal capital M mass into here where capital M tons, no, 1000 in kilogram weight. Acceleration 0, then P equal to R. Resistance and tractive force same. Then use H equal PV, H kilowatt 1000, H tractive force P, that instant velocity U, then P value 1000 H divided by U. Then R value same. Thereafter, it says that move along a track, straight rod with inclination alpha to the horizontal. Now here it is now. Capital mg, m into 1000 g. Then new tractive force mark P1, resistance, same resistance, say R. Then by this one, therefore, resistance R equal 1000 H divided by U, no? 1000 H divided by U. Then you can use F equals MA. Show that the maximum speed of the lorry. So consider V maximum speed. Maximum speed. Therefore, acceleration 0. Here, use F equals MA, P1 minus R minus M into 1000 G sin alpha, 1000 M times 0. Acceleration 0. Now P1, R plus 1000 M G sin alpha. R mean 1000 H divided by U, 1000 mg sin alpha. Here tractive force. Now at that time its power 2h kilowatts. So we have to find velocity v. Now thereafter use H equal PV formula. Finally use H equal PV formula. Then 2h kilowatt, 1000 P1, that instant velocity v. Then v equal 2000 H divided by P1. P1 means this. 1000 H divided by U, 1000 mg sin alpha divided by sin alpha. Then cancel 1000. 2HU H plus mgu sin alpha. Always we need to manage H equal Pv, F equals Ma and equation of motion. Okay, 2016, so when you complete these questions, you can complete remaining past paper questions. Then go to remaining past paper question, then complete. 2016, a car of mass m kilograms moves along a straight level road. Capital Mg, resistance R. At that instant, moving its speed v. Here mark tractive force P, that instant velocity v, acceleration A. Then use F equals Ma, P minus R equal Ma. Then P equal R plus Ma. Then use H equal PV. Then we need to find power. Tractive force R plus ma, that instant velocity v. Here power. R plus mav. The car then moves with constant speed v1. Constant speed v1. That means acceleration 0. Against a resistance of same magnitude r up a straight road inclination alpha to the horizontal. Now that moving up with inclination alpha, let this power P1, capital Mg, resistance R, same resistance. Now velocity V1 constant, therefore acceleration 0. Then use this way, F equals ma, P1 minus R minus mg sin alpha equal m times 0. Then P1 R plus mg sin alpha. Then use H equal PV. Then same power H. H mean R ma v. We know that. Then tractive force P1 R plus mg sin alpha times V1. Then subject V1. R plus MAV over R plus mg sin alpha. R plus mg sin alpha. Continue. (2019) 17, a truck of mass capital M towing a car of mass capital simple M. Here simple mg, here capital Mg, here there's an engine, light inextensible string, mark tension T, the resistance of the motion of the truck and the car, lambda m, here lambda capital M, here lambda simple m resistance, mark tractive force P, lambda positive. At a certain instant, the power generated by the engine, capital P, then power capital P kilowatts, 1000 P watts. The speed of the truck V, here velocity V, speed V, but acceleration, there can be acceleration because that is not maximum velocity or constant velocity. Therefore, you use H equal PV now, 1000 P, tractive force mark P1, that instant velocity V, then P1, 1000 P over V. Then use F equals ma, full system. Then P1 minus lambda m resistance, lambda capital M resistance, total mass m plus m, its acceleration say a, because we don't know exactly whether it has acceleration or not. But anyway, the velocity changes not given. Therefore, you take there can be acceleration. Then P1, 1000 P over V minus lambda m plus m plus m a. Then acceleration 1000 P over V m plus m minus lambda. Acceleration. Show that the tension of the cable. Now we need to find the tension. Now consider only vehicle car. take only car, use F equals m. T minus lambda m equals simple ma. Simple ma. Then T equal lambda m plus simple ma. 1000 p over v m plus m minus lambda. Then 1000 m p over v m plus mv. M plus mv. Okay. In 2018 question. A car of mass 1200 kilograms moves it, the engine shut off. So engine shut off means no tractive force. Down straight road, inclination alpha to the horizontal. Here alpha. Here the car 1200 G. Then there will be resistance R. Then alpha sin alpha 1 over 30 inclination. G10. Then G10. Now that is in Newton. Find resistance. Use F equals ma. Okay. 1200, 12,000 sin alpha minus R mass 1200 into acceleration. Acceleration certain constant speed, no? And acceleration 0, certain constant speed. Then R equal 12,000 sin alpha 1 over 30. Resistance 400 Newton. Find the power of the engine thereafter. When the car ascends the same road. So now it ascend 12,000 Newton weight, resistance R, tractive force P, new tractive force P. That instant acceleration 1 over 6 meters per square seconds and velocity 15 meters per second. Alpha. Then use F equals ma, P minus R minus 12,000 sin alpha 1200 times acceleration 1 over 6. Simplify. P, R mean 400, take all the other side. 400, 12,000, sin alpha 1 over 30 plus 200. P 1000, 1000. Then use H equal PV. H equal PV. Tractive force 1000, that instant velocity 15. Then 15 kilowatts. 15 kilowatts. Continue. Then 2019, Com.Maths capital M, constant power capital P moves downward along straight road, inclination alpha to the horizontal, with constant resistance R. Yeah, alpha inclination, mg, resistance R. That instant acceleration A. Here mark tractive force P, say P1, power P kilowatts, 1000 P. Find the velocity of the car at that instant. Okay. Then downward F equals MA, P1 minus R plus mg sin alpha. Capital M times acceleration A. Then P1 equal MA plus R minus mg sin alpha. Then use H equal PV. H equal 1000 P, tractive force MA plus R minus mg sin alpha times V, that instant velocity V. Find the velocity of the car that instant. V equal then 1000 P over MA plus R minus mg sin alpha. Velocity at that instant. Deduce the constant speed with the car can move along the road. Constant speed. So we need to deduce this. Then constant speed, acceleration 0. Therefore A 0. Then constant speed V equal 1000 P over, take A 0, R minus mg sin alpha. R minus mg sin alpha. Continue. Okay. 2020 A level question. A car of mass 1500 kilograms, resistance 500 Newton, power 50 kilowatts. Mark tractive force P, H equal PV. Then 50 times 1000 PV. With speed 25. P equal 2000 Newton. At that instant, engine of the car is turned off. Now engine of the car turned off, that means tractive force gone. Find the speed of the car after 50 seconds. From the instant the engine was turned off. So at that time velocity V, at that time velocity 25, initially 25. Now it has only resistance 500. Use F equals ma to find retardation. Minus 500 mass 1500 A equal 1/3 minus retardation. Then we need to find velocity. Then V equal U plus AT. Initial velocity 25, here 1/3 T after 50 seconds. 50. Then 25 over 3 meters per second. 25 over 3 meters per second. මෙතනදී acceleration එක ගන්නක් තියෙනවානේ F equals ma දාන්න. Acceleration 2000 minus 500 1500 A1. Yeah, acceleration A equal 1 meters per second. Meters per square seconds. Here acceleration. Okay. Then 2021. A car of mass m moves upwards with constant acceleration along the straight road with inclination sin inverse 120. Sin inverse 120. Constant resistance R. Then 36 kilometers per hour in meters per second, 36 into 1000, 3600 meters per second, then 10 meters per second, then 72 kilometers per hour, 20 meters per second. So it takes displacement 50, 500 meters to reach that velocity. Obtain sufficient equation. Now need to find them. Obtain sufficient equation to determine the power exerted by the car when its speed 54 kilometers per hour. 54 kilometers per hour. Okay. Then here V square equal U squared plus 2AS formula. V here 20 square, 10 square minus 2, acceleration take A, displacement 500. Then here 400, 100, 300, equal 1000 A, 300. A equal 1 over 3 over 10. Here acceleration, 3 over 10 acceleration. Then when its velocity 54 kilometers per hour, 54 kilometers per hour. Then here 15 meters per second, 15 meters per second. Then mark tractive force P. Then use F equals ma, P minus R minus mg sin alpha equal m acceleration A. Take acceleration A. Then A value 10 over 3. No? Here first equation, second equation, use H equal PV now. Then H equal P, here find P value, R plus mg sin alpha plus ma. A mean 3 over 10. That instant velocity 15 into 15. Here watts. That is the power of the engine, 15 into 15. Okay, then 2022 A-level question. 2022 A-level question. A car of mass 1,500 kilogram working with constant power 80 kilowatts moves on horizontal road against constant resistance. Here tractive force P, resistance R, acceleration 2. Use this as F equals ma, P minus R 1500 A mean 2. Then P minus R equal 3000, first equation. When it moves at speed 20, now this time velocity 20. Then use H equal PV. Then H equal 80 times 1000, P, that instant velocity 20. Then P equal 4000. Therefore, R equal 1000. R equal 1000. Obtain equation sufficient to determine the acceleration of the car. Now inclination alpha, sin inverse 2 over 3. Sin inverse 2 over 3. With speed 8. Here 8. Then there can be acceleration A. Mark forces here. 1500 G. Newton. Mark tractive force P1. Resistance R. Same resistance, same power. Then use H equal PV. H value 80. 1000. P1 velocity 8. Then P1 equal 10,000 Newton. 10,000 Newton. F equals ma, P1 minus R minus 15,000 sin alpha equal 1500 A. Now P1 known, here AR, R known, P1 known, R known, you can find A, can obtain A. Here we need to get only sufficient equations now. Then Sufficient equation determine A. This is enough. Okay, then start 2000 A level question. 2000. Okay, 2000 A level question. An engine working constant power 500 kilowatts, pulling up with inclination 1 in 196. Then sin alpha 1 over 196. Two 2.5 10 to the power 5g. Tractive force P, resistance R, speed 24, 24 kilometers per hour, acceleration 0.2, meters per square seconds. Then H 500 into 10 to the power 3 watts. V equal 24. V equal 24 into 1000, 3600. 20 over 3 meters per second. Okay, then H equal PV 500 in 10 to the power 3 PV. Then P equal 75,000 newtons. Then use F equals MA, P minus R 2.5 G 5 times 10 to the power 5 G mean 10 sin alpha mass into 2.5 10 to the power 5 into acceleration 0.2. $75,000 R here 25 10 to the power 5 sin alpha 1 over 196 here 9 G equal here 2.2550 10 to the power 3. Okay, then here 25,000 25 10 to the power 5 G 9.8 25 10 to the power 4 98 196 here 1 2 0 equal R. $25,000 over 2. Newton. 25,000 over 2. 12,500. 12,500 newton. හරි අපි පටන් ගමු නේද? මේකේ අන්තිම හරියේ කොටස් වලට අපි යමු. 20. Okay. Before that, see this one. See this concept. Huh? Consider here a tank. Here a tank. I'm going to pull water with speed V. Here tube area A. Area of the tube A. So that must be done by using a motor. Here a motor. Then consider here velocity V, no? Velocity V. Then per second volume. 1 second volume. Volume per 1 second. 1 second. Here area A, displacement V, AV. AV. Then mass per 1 second. Mass per 1 second. Then AV rho. AV rho. Mass per 1 second. Usually we denote by m dot. M dot. Mass per 1 second. Then total energy. Total energy required per 1 second. So here we need kinetic energy only. Half m dot v squared. Half m dot v squared. Energy need. Then half m dot mean a v rho v squared. Then 1 over 2 a v cube rho. Then 1 second total energy required we call power. We call power. Then here required power half AV rho cube. Half AV rho cube. Here motor 1. Motor 1, M1. Then consider another motor. Need to pull this water H height and need to project with velocity V. Project with velocity V. Then total energy required per second. Total energy required per second. That case we need kinetic energy and potential energy both. Therefore total energy for 1 second. Here half m dot v square plus m dot gh. M dot gh. Then that is power. Here power. Power of the engine. Then m dot mean AV rho. M dot mean AV rho. Then you can find full power here. 1 over 2 AV cube rho plus AV rho GH. Here total power. Okay. Put this note. Okay. මේ type question එකක් එහෙම අහලා නැහැ. කොහොකටත් ඒ වෙලේ concept එක තමයි අපි ගන්නෙ. ඒ කියන්නේ power එක කියන එකේ concept එක work done per unit time කියන එක. ඒතර work done per unit time කියන එකෙන් තමයි හැම concept ඔක්කොම හැම දෙයක්ම හැදෙන්නේ. ඒකෙන් තමයි මේක අපි ගත්තේ. දැන් හිතන්නකො කවුරු හරි එක්කෙනෙක් පහළ තියෙන ගල් අරගෙන උස්සලා විසි කරනවා කියලා. ඒතර ඔහම උස්සලා විසි කරනවා දිගටම එකම විදිහට කරනවා කියලා හිතන්න. ඒතර එයාට ඕනේ power එක හොයන්න තියෙනවනම් ඒ ගලේ තියෙන mass එක අරගෙන height එක අරගෙන ඒකෙන් potential energy ගන්නවා. ඊට පස්සේ kinetic energy ගන්නවා. ඒතර එක විනාඩියකට කොච්චරක්ද කියලා දීලා තියෙනවා per second එයාට energy එක ගන්නවා. ඊට පස්සේ ඒකෙන් power එක අපි කියනවා. අන්න ඒ විදිහට යන්න පුළුවන්. හරිද? ඒ කියන්නේ විනාඩියකට ගල් 100ක් විසි කරනවා කියලා හිතන්නකෝ. ඒතර විනාඩියට ගල් 100ක් විසි කරනවා නම් එක තප්පරයට එන්නේ 100 බෙදීම 60යි නේ. ඒතර 100 බෙදීම 60යි. ඒතර එකකට ඕන එනර්ජි එක කියන්නේ half mu square plus mgh. ඒතර ඒක එකකට ඒක 60න් වැඩි කරා නම් මේ sorry 100 බෙදීම 60න් වැඩි කරා නම් හරිනේ. ඒ තමයි total power එක required power එක. okay. අපි මේකේ ඉතිරි ප්‍රශ්න ටිකට සෙට් වෙමු නේද? තව ප්‍රශ්න දෙක තුනක් තියෙනවා. ඒ ටිකත් අපි ඉවර කළාම දාමු. 2001 A level question. 2001 2001 A level question. Greatest speed of a car of mass 1000 kg moving on straight horizontal road is 144 kilometers per hour. Then convert into SI units. One four four thousand over 3,600. 40 meters per second. Mass 1000 kilogram, 1000 G. Then power H equals 16 kilowatts. Now, need to show that, no? Here resistance R. Take tractive force P. At maximum velocity here, maximum velocity, then acceleration 0. Acceleration 0. Resistance 400 newtons. Here, use F equals ma, P minus 400 equal 1000 A value 0. Then P equal 400 Newton. Then H equal PV. Tractive force 400, that instant velocity 40 kilowatts, 16 kilowatts. The car pulls a trailer 600 kilograms. Same road against additional resistance 200. Now again, sketch it. Here, car and the trailer, T, tractive force, let's say P1. So new resistance 200 Newton, previous resistance 400 Newton. When it velocity V, 124 kilometers per hour. Same power. Then use H equal PV, power 16,000. Tractive force P1, that instant velocity 24, convert into SI units, 1000 divided by 3,600. Then P1 24,000. Here 24,000 newtons. That is new tractive force. New tractive force. Find tension of the two ropes. Now you find acceleration. Use horizontally F equals ma. Then P1 minus R plus R1. Here total mass 1,600 times acceleration A. So here there can be acceleration, no? Then P1 2400 R 400 200 1600 A. Then A equal 9 divided by 8 meters per square seconds. Here new acceleration. Then consider only Taylor. Taylor use F equals ma. Then T minus 200. T minus 200 equal mass 600 A 9 of 8. 9 of 8. Then T value you simplify. 200. Then here 300 for 75 times 9. Okay. Find the value. (875 newtons). Okay. Now go to 2013 A-level question. 2013 A-level question. These are part B types. Part B types. Okay. 2013. A train of total mass 300 metric tons moves down straight track with inclination sin inverse 1/98 to the horizontal at constant speed with its engine turned off. Then no engine for now. Constant speed. Here alpha sin alpha 1/98. Take here the train 300 times 1000 G. Resistance R. Then use F equals ma. 3000 10 to the power 3 sin alpha, G sin alpha. Minus R. Here 3000 10 to the power 3 times acceleration 0. Here constant speed no. Therefore acceleration 0. Then R value 300 10 to the power G 3. G value 9.8. Here 1/98. R value. Now you simplify. 30 times 10 to the power 3 Newton resistance. Now here the resistance. If the magnitude of the frictional resistance of the upward motion remain the same constant value for the downward motion, then upward motion resistance same. Pull a train up with same track with constant speed 54 kilometers per hour is 900 kilowatt. Okay, then it moves up. Here 300 10 to the power 3 G. Angle alpha, resistance same R. Here need tractive force P. Now its velocity V 54 kilometers per hour. Constant. That means acceleration 0. Then use H equal PV first. H value. Before that use F equals ma. P minus R 10 to the power G sin alpha zero. P equal R 300 10 to the power 3g sine alpha. Then resistance, previous one, 30 times 10 to the power 3, 300 10 to the power 3, g mean 9.8, sine alpha 1 over 98. 60 times 10 to the power 3. Then use H equal PV. 60 times 10 to the power 3, that instant velocity 54. 54,000 divided by 3,600, that is meters per second. meters per second. 15. Now simplify. (900 kilowatts). 900 kilowatts. Okay, then thereafter we need to assume here assuming that the engine is working at this power when the train is traveling on straight horizontal track with speed 18 kilometers per hour with resistance same magnitude before. Now new tractive force take P2, resistance same R, then velocity V 18 kilometers per hour. 18, then 5 meters per second. 5 meters per second with resistance same, G 9.8. Find the acceleration of the train now. Then use H equal PV. X value 900 10 to the power 3, P2 5. Then P2 10 to the power 3 Newton. Okay, here P2 force. Then use F equals ma. Then P2 minus R equal 300 10 to the power 3 times 6. R value, resistance 30. Here 10 to the power 3, 10 to the power 3. 300 10 to the power 3 A. A value 15 over 3. 5 meters per square seconds. 5 meters per square seconds. Okay. Then try 2006. 2006. (2006). An electric train works at power 3000 kilowatts, maintain a constant speed 160 kilometers per hour on a level track. Calculate the resistance to its motion. Okay, now here tractive force mark P, resistance take R, then velocity 160 kilometers per hour, constant, that means acceleration 0. Then 160,000 divided by 3,600. Then it's divisible by 4, no? 4, 0, 9. 400 divided by 9 meters per second. Then its power 3000 kilowatts, 10 to the power 3 watts. Then use H equal P, here H equal PV, no? Then use H equal PV. PV 400 divided by 9. 30, 15, 7.5. 75, 00 into 9 equal P. $77,500. That is tractive force. Then use F equals ma. F equals ma. Then P minus R. M times acceleration 0. No? Then R value equal P. Resistance equal tractive force because constant velocity. When traveling with speed 60, the train operates with the same power as before while the resistance of the motors remains same. Find the acceleration of the train. Okay. Now this case, tractive force mark P, 1, resistance mark R. Now the velocity V is 60 kilometers per hour. Take acceleration A. Then 60,000 over 3,600. 100 over 6 meters per second velocity. Now H equal PV. H value 3000 10 to the power 3. Tractive force P1 100 divided by 6. Then simplify. Then P1 180 times 10 to the power 3. Then use F equals MA. Then P1 minus R equal MA. Then P1 180 times 10 to the power 3, resistance 67500, mass 300 10 to the power 3 times acceleration A. Sorry, upper hill, no? Upper hill. Here P1 3000 10 to the power 3 G. Resistance R. Then inclination 1 to 70. Then sin alpha 1 over 70. 1 over 70. Given that the mass of the train 450 metric tons. 450 metric tons. 10 to the power 3 mass. Then use F equals MA. P1 minus R minus minus 450 10 to the power 3g sin alpha equal 450 10 to the power 3a. Okay, then P1 180 10 to the power 3 67500 450 10 to the power 3 9.8 sin alpha 1 over 70 450 10 to the power 3a 10 to the power 3a. Then simplify and get the value. You can cancel 10 to the power 2 1800 675 here 450 45 98 1 over 7 450 0 and subject a value. Here divisible by 7 1 4. Okay, now further you can simplify. 1800 765 1 125 45 times 14 4500a. Okay, then get a value. Simplification චුට්ටක් check කරන්න වෙයිද දන්නේ. Go to 2002 හරි ඒ ලෙසන් එක අපිට එතන ඉවර කරන්න පුළුවන්. ඕකේ දැන් සාමාන්‍ය ගත්තොත් පාර්ට් A level එකේ ගාණක් තමයි දෙන්නේ. සාමාන්‍ය පොඩිම තැනක තියෙන ගාණක් තමයි දෙන්නේ. හැබැයි ඊට කලින් අවුරුදු වල පාර්ට් B ගණන් තිබිලා තියෙනවා. ඒ කියන්නේ 2013 12 ඒ වගේ රේන්ජ් එකෙම එකයි 10ට කලිනුයි පාර්ට් B type එකෙන් තිබිලා තියෙනවා. හැබැයි 10ට කලින් අවුරුද්දක දෙක වගේ තමයි තිබිලා තියෙන්නේ. දැන් ඔයාලට දෙන පේපර් එකේ හැටියට අනිවාර්යයෙන්ම part A එකේ ප්‍රශ්නයක් විදිහට තමයි දැන් තියෙන්නේ. කියන්නේ පොඩි ප්‍රශ්නයක් ලේසියෙන්ම ලකුණු ගන්න පුළුවන් ප්‍රශ්නයක් විදිහට තියෙන්නේ. එතකොට මේකේ තව එකම දෙයක් මම නිකන් කියන්න. සමහර තැන්වලදී මේ resistance එක වෙනස් වෙන හැටි කියන්නේ දැනට දුන්නේ constant resistance වල දුන්නේ. හැබැයි සමහර ලාවට ඔයාලට මෙහෙම තැනක් දෙන්න පුළුවන්. velocity v resistance r proportional to v කියලා. ඒ කියන්නේ velocity එකෙන් velocity එකට මේ r වෙනස් වෙනවා. then r equal kv. kv. තර v කියන එක නා මොකක් හරි 10 meters per second තිබුණොත් 10 meters per second then r1 equal 10k. v equal 20 meters per second then r2 equal 20k. v equal 5 meters per second r2 equal 5k. අන්න ඒ විදිහට velocity එකත් එක්ක resistance වෙනස් වෙනවා. ඒතර ඔයාලට proportional කියලා දුන්නොත් ඕක ඔය විදිහට. සමහරලාට ඕක දෙන්න පුළුවන් r proportional to v square කියලා velocity square. then r equal kv square. ඒ වගේ දෙන්න පුළුවන්. හරිද? ඒ වගේ පොඩි relation එකක් එක්ක velocity වෙනස් වෙන relation එකක් එක්ක resistance එක දෙන්න පුළුවන්. එහෙම දුන්නොත් මේක වගේ ගෙනියන්න පුළුවන්. ඒක නිකන් note එකක් දාගන්න ඔතන. just put that note. Resistance proportional with v. Then resistance equal kv. Then with velocity, resistance can be different. No? With velocity that can be varies. Then resistance equal proportional to v square. Then r equal kv squared. Okay. එතනින් අපිට එතකොට ඔය කියන කතාව ඉවර කරගන්න පුළුවන්. work power energy. ඔය ටියුට් එකේ අන්තිමටම තව questions එකක් තියෙනවා. කියන්නේ බේසික්ම level එකේ questions ටිකක් තියෙනවා. ඒ ටිකත් හැමෙහිට කරන්න. මොකද අපිට part 1 section එකක් ඉඳලා එතෙන්ට ඒක යන්න පුළුවන්. හැබැයි දැනට තියෙන හැටියට ඔය h equal pv apply කරන තැනට තමයි ඔක set වෙන්නේ. හරි. බලන්න ඒත් එක්කම මේ දැන් අපිට කොහොමද දැන් ඒ work power energy ඉවරයි. තව අපිට තියෙන්නේ හරි පොඩි lesson